for section 3.4. And I left off with solving logarithmic expressions or equations by converting to exponential form, and this is our third example. So we have log base 6 of x plus 4 plus log base 6 of x minus 1 equals 1. Well, the first thing I need to do is combine my logarithms, and since we're adding here, it means I can multiply them. So I'd get log base 6 of x plus 4 times x minus 1 equals 1. FOIL those through or box those through, and then you'll get log base 6 of x squared plus 3x minus 4 equals 1. Now I can convert to exponential form. So 6 is my base, 1 is my exponent, so 6 to the first equals x squared plus 3x minus 4. I can subtract 6 from both sides to get 0 equals x squared plus 3x minus 10. The next thing I'm going to do is factor. And so I get 0 equals x plus 5 times x minus 2. I get x equals negative 5 and 2. But what we need to do is check our answers. When I plug them back in, I get negative 5 plus 4. That gives me a negative 1. It's not possible to get a logarithm of a negative number. So right now, negative 5 is not going to work. That's an extraneous solution. Plug 2 in. 2 plus 4 is 6, and 2 minus 1 is 1. Those both stay positive. So my only answer is going to be x equals 2. And I'm going to say negative 5 is extraneous. So negative 5 is not considered a solution. It's extraneous because you can't take the logarithm of a negative number. The next part is the one-to-one logarithmic property. So we had a one-to-one exponential property. We also have a one-to-one logarithmic property. So this states that if you have log base b of m equals log base b of n, same bases, then that must mean m and n are equal. So in solving logarithmic equations, make sure you guys have the same base. Then you'll set m equal to n, like in step 1, and then you'll just solve for the variable. So the first, and then don't forget to check for extraneous solutions. Both m and n have to be positive in order for a solution to work. So in my first example, I have log base 5 of 2x equals log base 5 of 3x minus 5. My bases are the same on both sides, so I'm going to go ahead and set them equal to one another. 2x equals 3x minus 5, bring the 3x over, and then I get negative x equals negative 5, and x equals 5. So when I plug that back into my original equation, I get log base 5 of 10, and then 15 minus 5 is also 10, so that's positive. My only solution is 5, and that works. I don't have any extraneous solutions to worry about. On the second example, I have 2 log base 10 of x equals log of x plus 12. I want to use my logarithmic properties, so I'm going to change this to the exponent, so x squared equals log of negative x plus 12. Sorry, that should be negative. It should have been negative up in the first place. So then x squared equals negative x plus 12. Since my bases are the same, bring everything over to one side, so I get x squared plus x minus 12 is 0. Factor that out to be x plus 4 times x minus 3, and you get equal to 0. Zero product property, my x is negative 4 and 3. But now let's check to make sure I have, see if I have an extraneous solution. When I take negative 4 and I plug it into my original equation, I get log of a negative number. Negative 4 is extraneous and it's not going to work. When I take 3 and plug it in, it's going to be positive in both sides. So x equals 3 is my solution, and negative 4 is extraneous. So negative 4 is not considered a solution, but 3 is. And then this is the end of the video. I just wanted to point out some powers that you guys need to know how to find without a calculator. So you should know 2 all the way up to the power of 5 is 32. If you know 2 to the 6th, that's great. 3, you should know all the way up to the power of 4. 4 and 5, you should both know all the way up to the power of 3. And then you should also know 6, the number 6 through 12 squared, all the way through. This is without using a calculator. And then here is the assignment 18.